Problem solving by integration. Objective by in this lesson, you should be able to use integration to solve problems dealing with rates. That's kind of the key here. We're going to talk about rates. So if you remember when we first learned about kinematics, the original function, let's say s of t, was usually like in meters, and then when you take a derivative, you got v of t, and that was like in meters per second. You take a derivative again, you get like a of t, blah, blah, blah. That was like meters per second squared. Right, when you take a derivative, you go down and you divide by time. When you integrate, we're doing the opposite. So when you integrate, you go up and get v, and when you integrate this, you get s of t. And what's important about it is when you take a derivative, right, you're dividing by time. So you're dividing by s and then s squared. When you integrate, you lose, but you're going up a level, so you're like getting rid of that s. And that's kind of what we're going to be doing here. A lot of these problems we're going to be giving you the rate, which is velocity. That's where we're going to start. So they'll say something like r of t equals some rate, let's say miles per hour. Right, so let me put that in the proper, not proper, but like miles per hour. Right, so r t equals some rate miles per hour. And then I'm going to say find total miles traveled in, let's say 3 hours. So you're like, wait, the function I have here is miles per hour. How do I get miles? Well, you have to integrate. You gotta get rid of the h. You gotta integrate it. So that's what we're gonna do here. It's like, oh, I have a rate, and I want to just get miles. You gotta integrate that thing. So when you integrate it, you get the integral of that, which is this integral of rt, which is just gonna be in miles, because you go up. Right, so anytime you have like a rate, that's what we're going to start here, and you want to get rid of the rate, you just want the total amount of something, you integrate it. Or likewise, if they give you a function, they're saying you're integrating, they're asking what does that mean? Well, if it's a rate, then you're just getting the total amount. So that's kind of the general idea here, is that we're going to be giving you a rate, and we're going to have to integrate it to get the total amount. So let's do a couple of examples. The rate of power consumption by a city of Bristol can be modeled by the function this. So this is the rate of power consumption. So if I want the power consumption at 2 hours or something, I can plug in 2. So blah, 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 all this stuff, right? In gigawatts, where t is the number of hours at midnight each day, and where t is between 0 and 24. So hours at the midnight. So if you want it at 3 a.m., you plug in 3. So you want to know the power consumption at 3 a.m., plug in 3. Power consumption at 10, plug in 10 a.m., plug in 10, and so on. Find the following quantities and explain what they represent. So the thing to keep in mind here is that this is a rate, right? This is a rate. So this is a rate of power consumption. So when I integrate that, we're going up. Right, just like we did here. If you go up, you're getting the total amount. So it's the total amount of power. This would be the total amount of power. Or just the amount of power used from midnight to noon. So I guess you could say like the morning, total amount of power used in the morning. And then to find that out, we're just going to put this into our calculator. Now, since we're sine and cosine, I'm going to make sure in radians, but luckily my calculator defaults to radians. Let's talk about, so one way to do this is press math 9, right, f integral, that's 9, and then type that whole situation to here. Well, sorry, here, right? Whole equation, I'm going to go back and change the limits. And this way works fine. Like you go up and select and change the limits. I want to show you a shortcut. This may be specifically helpful if you ever take calculus in the future. So what I'm going to do is I'm going to get rid of this. I'm going to go to my y equals. I'm going to make a graph essentially. So I'm going to go to y equals, and under y1 I'm going to type all this in. So again, this should be in radians since we're doing sine and cosine. I'm going to put 0.04, 0.3, sine. I'll use a fraction bar, so alpha y equals. Right, which is the fraction bar up there. Then we're going to do parentheses x minus 10 times pi over 12. And then I got to close this parentheses. Plus 0.1 cosine alpha y equals. I like to try to make it look almost exactly like this as possible, as much like that as humanly possible. so I know I didn't mess up somewhere. That over 6, and then again close this parenthesis, and then plus 0.775. Okay, so it's all typed in the graph. I'm not going to graph, I'm just using that as a kind of placeholder. So I'm going to get out of here. I'm going to go back to my integral, so math, number 9 is integral. So I keep on clicking so you can see it. I can also just press math 9 and it'll work. Right, math 9. And I'm going to do the limits, 0 to 12. And instead of writing out the whole function like we just did, I'm gonna select y1 because that's where I place it under. So the way you select y1 is you press alpha and F4, and there's y1, right? So it's putting that equation, the equation we put right here, is putting that in for y1. And then we're going to take an integral from x, and we get our answer. So this one's just 7.315 or 7.32 gigawatts. Not gigawatt, to be power consumption. I don't know what the actual unit is. Gigawatts is not like it's a rate, but it's not my forte. So there's that one. Then we're going to do something with 12. So this one you can see from 12 to 24, it's to me the same idea. It's the amount of power used. I'm going to do this because I'm lazy. The amount of power used from noon to midnight. You might call that the afternoon. So I'm going to go, remember all I did was go back up here and select my equation. I'm going to change the limits this time from 12 to 24. Press enter. I get about 11.2. Makes sense. More people probably use power at night. And then the last one, this looks like the amount of power used all day. Alright, I'm just copying that all there. That I've had a chance to write all that here and here, and then all day from 0 to 24. And then I'm going to go back and select my thing and go from 0 to 24. I'm going to delete that too. There we go. Come on. 18.6. Which makes sense. It's really just this function plus that function. I just add these two. I didn't have to do the math on it. It's this plus that. It'll give me this. But there we go. Okay, let's do one more quick example. Evan is happily paddling until his kayak strikes a sharp rock. Water begins to leak at a rate of this amount, liters per minute. So this is my first rate. So this is water leaking out of the boat. And notice it's in liters per minute. Right, it's a rate. So if I integrate this, I'm just going to get just liters. Evan tries to bail the water out of the kayak, moving the water at a rate of this. So this is our other rate. We have two rates here. Again, liters per minute. Many times when there's two rates like we have here, one one's a positive value and one's a negative value. Water's being leaked into, or water's leaking into the boat. So this is like our plus. And then it says we're trying to remove the water so our boat doesn't sink. So that'd be our minus right there. So it's a plus value and a minus value. Okay, so let's go to the first question. After 2 minutes, at what rate is the water leaking into the kayak? So leaking into the kayak is this formula. Now notice the question though. At what rate? This is a rate. It didn't say like how many liters, which I would need to integrate this. It didn't say how many liters per minute, which I would have to take a derivative of this. It wants to know what rate. That's just this guy. All we do for this one is plug 2 into that rate and get our answer. I'm going to do that in a second. Being bailed from the kayak. So again, what rate? This is a rate at which water is being bailed out of the kayak. So what's that plug 2 into that equation also? And that gives us both our rates. So for that we need our calculator. And now, again, these rates, I'm going to take a little shortcut. I'm going to put them into the y equals. I'm going to delete this. I'm going to put this in there instead. I could just plug 2 into there also, and that'd be fine. But I'm going to need to reuse these equations. So since I'm doing that, I'm just going to put them in y1 and y2. It's a little like math shortcut for when I have to reuse the same equations all the time. I use the wrong e. Well, not the wrong e, but the less efficient e. So negative 0.2x. And then this one is 6 minus 6. It's the e. Let's see that now. Negative 0.1x. Okay, so they're both in there. Now this one's a little tricky. How do I plug 2 into the first equation, my y1? I'm going to go alpha trace y1, and then I'm going to put parentheses 2. That's letting the calculator know I want you to plug 2 into the y1 function, which for me is r1. And we get 1.64 liters per minute, right? Because that is the rate. We're just plugging into this equation. So I get 1.64 liters per minute. That water is leaking into the ship. Now let's plug it into the second one, or substitute it into the second one. So I'm going to go alpha at 4. I'm going to select y2, which is our water, how fast we're taking it out. Again at 2. And we get 1.09 liters per minute. So remember my signs here. Water's going in at 1.64. Water's coming out at 1.09. We're fighting a losing battle here. More water's coming in than we're taking out. So the question here is the amount of water in the kayak increasing or decreasing at their 2 minutes? Explain your answer. So like we just talked about, at 2 minutes, more water's coming in than coming out. So the water in the kayak's increasing at 2 minutes because the rate 1 of 2 is greater than the rate 1 of 2 of 2. This is water coming in. This is water out. Since this rate is higher than that rate, there's more water coming in. Evaluate the following integrals, interpret their meaning. So in this case, we're integrating from 0 to 3 of R1. Remember, that's the water coming into the kayak. So this is the amount of liters water coming in to kayak. The amount of water into the kayak from 0 to 3 minutes in liters, right? Because again, what's going on here? We're liters per minute. So we're integrating from 0 to 3. So that means we're integrating this function here. So we don't get liters per minute. We just get liters. So the total amount of liters that came into the kayak from 0 to 3 minutes. That's what's going on there. So this is when water coming into the kayak. So the total amount going into the kayak from there. And again, on my calculator, I'm going to figure that out. So math 9, we're going from 0 to 3. That's our first equation, or y1. So I'm going to go here, press alpha F4, y1, and then we're going to go here and press X. So 3.72. So it's 3.72 liters of water that have gone into the kayak in the first 3 minutes. R2, right? This is water coming out. Coming out of kayak. So that's just its amount of water from 2 to 5. So maybe it took us 2 minutes to realize that we sprung a leak. Anyway, so if I want to do that one, I'm going to net math 9. Right, we're going to go 2 to 5. And now we're going to use the second equation, F2, at X. 5.26 liters. The next one, from 0 to 8, R1 minus R2. So let's talk about what this means. R1 is water coming in. R2 is water coming out. So this will be the total amount of water in boats after 8 minutes. So, right, water in minus water out, we're going to figure out how much water we have in the boat after 8 minutes. So I'm going to go here, I'm going to type it in. So math 9, I'm going to go from 0 to 8 of y1 minus y2. So alpha F4 y1 minus alpha F4 y2. And that's the x with respect to x. And we get about 5.081. So about 5.09 liters. So that's how much water is in the boat after 8 minutes. So about 5 liters in the boat. I'm not sure how much the kayak could hold, but about 5 liters at 30 minutes. How much water is in the kayak after 10 minutes? Well, again, since they're giving us, we're going to integrate, so we're just going to change the limits from 0 to 8 to 0 to 10. So let's go up here, click that, and select 0 to 10. And we get 6.3106. So about 6.31 liters. It looks like we're fighting a losing battle here. Anyway, that's a lesson.